large language models over the past few years have been shown to be super excellent at interfacing with language. So they have some flaws. There's some things they're not good at, but one of the things they're really good at is taking in text and writing more text and using that as a way of having language be the interface into whatever you're building. So the way we create these is we take as much text as we can get from the web, and we turn that into a data set. And the data set just looks like about we'll have a bunch of examples of like, maybe we'll have a page of text, and we'll give it the first half of that text, and then we'll train a neural net to try to predict the second half. That's it. We just do that over and over again on this neural net until it gets very good at predicting what text is likely to come next. The reason why I talk about this when explaining neural nets to people who are just getting into the field is that it can often feel like magic, like when you're talking to a chat model or you're sampling from a transformer. It can feel like you're talking to some crazy magic thing where you put in a question and out comes an answer, or you give it a command and out comes something else. But it's not. It's really just a probabilistic model of sequences of text. So you write, "Hello, how are you doing?" And it's quite likely that you would say "today" next or something. And so that's what the model does. I see a question from Zoya saying, how much data do you need for this to be effective? There's actually two answers to that question. And that's because training these models comes in two steps. The first step is baseline training. So we just train the model to be good at language in general. And how much data do you need for that? A huge amount. As much data as you can possibly get. Cohere, like, we train our baseline models off of data taken from the open web. So we feed it like, all the open source books we can get, and any website that's being hosted that a bot can crawl. We try to get that data and process it so that we just get the text from that website. So really like terabytes of text in the end. And then there's a second step, and that second step is where we fine tune the model to be good at following instructions. And that's what goes into creating our like command models. And those are really the ones that we're going to be talking about today, because it turns out those are way easier to use because they've been fine tuned to be specifically tailored to people using them. So that's the thing.
I want to say like one thing. Presumably you are here because you're a developer and you're like, well, maybe I could use some AI in my apps. Let's see how this works. So while we do talk a lot about some specific machine learning concepts, you don't really need to understand all of them. And if you're lost, that's totally okay. At the end of the day, you just need to figure out, what could this be useful for in my app? And how do I do it really, really easily? And the other thing to understand is basically what we have is these models that have looked at Wikipedia. They looked at Reddit. They spent a lot of time browsing the internet and reading text on there. And what they've come out with out of that exercise is now they kind of know how to sound like a human. So the model Nick is going to talk about now is a model where you can ask it something and it will think about, well, how would a human answer this? And it will produce some text that sounds human when answering that question.
Yeah, cool. Okay, so let's flip over to, I see another question from Brian. Is this similar to how Gmail now gives you suggestions? Yeah, it is similar. Yeah, so Gmail is doing, like, as you're writing, it's using machine learning to predict what a likely completion of that would be. And then if it thinks it finds a very likely one, it shows that to you. So yeah, quite similar, except we're using significantly larger models trained on different stuff. I think I'm pretty sure the Gmail models are like smaller in scale, and they're more restricted to that like one use case, whereas the ones we're creating are just general purpose command following models. Cool. Okay, so I'm going to share my screen. And I will share, so this is our website. This is a playground that we've created, and we created this so that you can play with the models and see what they're good at. And you can figure out a prompt that works for the task you're trying to solve, and then you can export the code. So if you're just beginning to develop on this, I highly recommend going to the playground and playing around to figure out what the model is good and what the model is bad at.
How do you reach the playground?
You reach the playground by going to our website, go here, AI, and then clicking Get Started, and that brings you to the dashboard. This is where you can like log in and see your API keys and billing and team, and I'll look at the model cards, and then click Playground, and that will bring you here. Thank you, Michael. Okay, cool. So this is a prompt I wrote. I wrote a prompt that says, write a list of 5 names for a really nice cat. And if I click generate, I will generate. Here are
Snuggles,
5 ideas for the next cat. Snuggles,
Blanche,
Cuddles,
Cuddles,
Grim, and Puff.
Puff.
Okay, cool.
Wait,
Let's,
can we try terrible cat?
yeah, so let's see what happens if I say a really terrible and mean cat. And if I generate from this, it will say Grumpus Maximus, Snarticus Nebulus, Gooseman, Sedaticus. Great. All right, cool. Let's Grizzware Grinder. Okay, let's try again. So really mean cat, Scrapper, Scratch, Scrounger, Scrummer. Yeah. Anyways, the reason why I do this is I'm demonstrating 2 things. One, like, it's listening to the language, and it's because it's been fine-tuned. It's because it's trained on the baseline web text and then fine-tuned on what people would expect. Even subtle things like this, like saying a nice cat or a mean cat, like you get affects the output, and we can see that it's aligned with mostly what we'd expect. This isn't super useful, right? Like I don't in terms
Objection.
of okay. But like in terms of what you guys want to build, like it's probably not often that you're going to come into building an app where you're like, what the user needs is an infinite number of names for a mean cat. It's much more likely that what you're going to come up with is something that like solves a problem for you. So for instance, let's imagine Michael and I are talking and we have a chat that looks like this. Michael.
That's not how you spell my name.
Oh, in this example, it is. I just got this great cat. And then Nick says, so cool. What did you call her? And then fine. And then Michael says, her name is Mel. And then Nick says, what kind of a cat? So imagine we have this chat and I want to extract the name of the cat here. So if I say like extract the name of the cat mentioned in the chat below. And now I'm going to sample from this model. Oh, oops. Oh, sorry. Use our bigger model here because this is actually getting a little complicated. So cat name. This is like, imagine you're making a chat. You have a chatbot and you want to always be reading if somebody's mentioning a cat or something. And so we could grab the history of the chat, pump it into this model, which will read, like this is again the prompt. That's all we're giving the model. And out comes the name of the cat.
She's a great cat.
Yeah, this is the name of Michael's cat, by the way, and she is really a lovely cat.
I'm gonna add pictures into the slides.
Sure. Yeah. So by being careful about what we're giving it, we can get behavior that's actually actionable for some application to do. Like you could imagine if you want to write some like bot or a Twitter bot or something or a Discord bot that is always in a cat themed Discord, and anytime a new cat is mentioned, you want to like take some action or something. You could write a prompt that would look like this. So what I've given it is some priming to say what it's going to do. Then I've given it the chat, which you would replace with the history that you were pulling from some app. And finally, you give it an extra prompt just to make sure that it does that exact thing. But we can take this a step further. And instead of just doing a chat name, here's a really long prompt that is like very specific. So this is a prompt that says, it's very similar to the last one. It's extracting something, except instead of it just extracting a single chat name, I'm actually extracting a full JSON object that gives me a whole bunch of information about a transcript. So here I say, extract the following information from the phone conversation below. Here's 7 things I want the model to extract. I have some details about what it should look like make sure the fields 1 to 6 are answered in very short sentences. 7, I want it to be a detailed summary, so I didn't want to say 1 to 7. Then I say, please answer it in a JSON machine readable format. And I tell some things about what the JSON should be. It should have a results object. I give it the phone conversation. And then I put JSON : and I extract from this. And here we get a fully properly formatted JSON object. Here, I can show you the whole thing here. That shows you the results, the reason, accident, cause, pothole, driver's names, which are in a list and properly formatted, insurance number, location. car damage, and here's a summary of what happened. So you can imagine if you were an insurance company and people were calling you and you wanted to make sure that you got all their information correctly, you could take the transcript of that call, pass it through this prompt where you replaced this transcript with whatever the transcript you got, and then you would just get this JSON object out. And so that's suddenly like super actionable. So the point here is you can take these general purpose models, which just are trained to follow commands, and then give them a prompt, which gives them something that's really
trying to figure it out.
Sorry, realized that. Oh, yes. Okay, great. So I realized I hadn't seen the chat, but now I realize it's all just people saying it's about cats, and that's lovely. The rest of the talk will not entirely be cat-based. Cool. So let's pass it over to Michael to look at what this looks like in code.
Okay. Can you hear me well? Because I'm speaking into Nick's computer. Can someone type in the chat that you can hear me? And if it's
yes.
Okay, great. So we're going to start in the playground, because that's where you usually start. I'm going to share my screen. There we go. Well, first of all, no, we're not going to start in the playground. We're going to start here. This is a picture of my cat. This is Mel. Right before I got her, she's the best. Moving on to the playground. Yeah, the playground is a website where you can just kind of toy around with building the right prompt to do the thing that you want. So when you visit the playground, you'll see a bunch of different things on the top: generate, embed, classify, and you won't see this beta, but I see it because that's something I'm working on called Summarize. Generate, embed, and classify, those are all the different APIs that we offer at Cohere. The one Nick has been talking about today is called generate. I was like, how do I hide this? There we go, it's hidden. Yeah, it's called generate. And generate, like we've seen before, you give it an instruction like, what's the best name for a cat? And then if it says something that's not Mel, I quit. Let's find out. Oh, it's using the wrong model.
Oh, actually, this is a good moment. So the model he just pulled from was not the command following one. So that was just a model that's good at general purpose text, not at following commands.
I'll go into this in a second.
Yeah.
Okay, great. The best name for a cat is one that you and your family love and fits the personality of the cat. Some popular cat names include Luna, Boone, and Charlie.
That's great.
All right, this is not an offensive answer. I'll accept it. I stay. What's going on here? So we have the input, the prompt. We have the output, which is what the model responded to my prompt with. And we have all these parameters on the right. Let's kind of look through them and see what's going on. Well, the first one is the model. The model, you can think about it as essentially like, who's answering this question? Is command medium nightly answering this question? Is command extra large nightly answering this question? All these different models are the ones we trained on different amounts of information. And if it's trained on less information and it's named something like medium, it means it runs a little bit faster, but it knows a little bit less. And if something is called extra large, it means it knows a lot more, but it's a little bit slower. So it's kind of up to you what works best for you. We're going to look at the command nightly command model, command extra large nightly. Let's kind of think about what the name means, command. Well, command are specific types of models that not only know a lot of information, but you can also talk to them with instructions. You can tell them like, what's the best name of the cat? Or write me an essay that I promise not to plagiarize. And it will do that for you. Other models work differently. So we're only going to focus on command because this one is really intuitive to work with. And the extra large next to it, like I said, just means it knows a lot of information and it runs a little bit slower. Nightly means we're updating it very, very frequently, which means from today to next week, it might get much, much better. Okay, cool. So we selected command extra large nightly. We have a prompt. What else can we do? Well, we have here the number of words, or specifically the number of tokens. Models don't really speak words. They speak in tokens. It's kind of weird to think about, to wrap your head around. A token is approximately one syllable. That's kind of how I think about it. But at the end of the day, what you want to say is like approximately how many tokens or how many words do you want to generate? And if you set something like 10,000, doesn't mean that that's how many it's going to make. It just means that's up to, that's the maximum number of tokens it's going to spit out. And then we have randomness. If you want something that predictably spits out the same thing every time you call it, you want to set randomness to 0. Or you could set it to something crazy and then, go to town. It's your life. All right, so let's play around with this. Let's say, what's the best name for a cat? Let's set it for randomness or temperature, what it's called scientifically, to 0. Let's see what happens. Sure.
One thing to note is that if you have a really high number of words, it will take longer for the model to generate because it's going to try to generate that whole thing. So, yeah.
All right. There's no one answer to this question, as different people may have different opinions. If we run this again, hopefully the answer we get is either going to be the same or very similar. Let's see what happens.
So for the extractive case, like the JSON stuff that I was showing you, you almost always want to use a really low temperature because you don't want it to be creative. You just want it to solve the problem. So yeah, here
right.
The exact
so
same
if you want to set the temperature or the randomness to something high, it means like, yeah, let me generate one. Let me generate another one. Why not? Something different. But if you always want something that predictably gives you the answer, set the temperature to 0. And we're using the words temperature and randomness interchangeably. Okay, cool. So now we kind of figured out our ideal prompt. What's the best name for a cat? Actually, is this the ideal prompt? Probably, let's say it is the ideal prompt. How do we plug this into our application? Well, right here on the top right, there's this view code button. And if you click it, it's gonna give you a code snippet. We have language-specific libraries. We have one for Python, for Node, for Go. You can also just hit it like a regular HTTP request. And you'll notice that it populates quite a lot of information here. Well, it chose the model that you selected on the right. It included the prompt, excellent. The maximum number of tokens, temperature, but then there's also like all this other stuff, K, P, frequency penalty. Those are all optional parameters. They show up on the right here under advanced parameters.
No fucking idea.
You can just copy this code snippet and not worry about them. You can also remove them. We have defaults for them. But just so you know, don't be terrified if you see all the stuff that you don't know. They're just like additional ways to control how the model behaves that we're not going to go into right now. Okay, and what does this look like in code? So I'm gonna jump into my code editor. Over here, I set up a little node server. I'm assuming that you know a little bit of JavaScript. If you don't, that's okay. We're not going to spend too much time in the nitty-gritty details of JavaScript. But basically what I have here is a little server. And right now, if I save it and run it, let's try that just to make sure it works. Going to hit my server. And it says, hello from Michael and Nick. Why does it say that? Well, because that's what I'm sending back. Let me not send that. And instead, we're going to use the Cohere library. First thing we're going to do is we're going to import it. Over here, we have constant co, and then require Cohere AI. Why co? It's just cute. We like calling Cohere co. So anytime we interact with Cohere, we do it with co, with things like co-generate, co-embed, and co-classify. So the API we're working with is generate. So our call is going to look like this. It's going to be like co-generate. Let's see what's inside of co-generate. We have our model parameter, which we decided is going to be command extra large nightly, the maximum number of tokens to generate, and then the prompt. And the prompt, I pretty much, you can copy paste it from the playground. Over here, I came up with a different prompt. It says, come up with a title and a synopsis of an episode of the TV show Friends that doesn't exist. Let's see what it does. So I'm going to save this and run it. And here we go. I find that these episodes often can be quite risque. Let's see. Things might be terribly, terribly broken. Nope, they're not. It's just command extra large is on the slower side. Okay, well, let's see the title. The one with all the resolutions. This is sick because all the episodes of the TV show Friends start with the one with or the one where. So this is relevant to Friends. Synopsis. It's New Year's Eve and the gang is getting together to celebrate. Each one of them has a different resolution for the year and they all want to stick to them. But will they be able to? I want to watch this. Okay, so this is sick. You can imagine you could build a cute app, web app that, whenever people visit it, it spits out a new episode of the TV show Friends and tell you what happens in it. And then later you could write another prompt that says, given this synopsis, what happens to Joey? And then it would maybe come up with a story for what happens to Joey. So that's the API we've been talking about called Generate. I think it's really, the reason we start with Generate is because it's very intuitive. You can kind of talk to it and it talks back. But also it's one of the two main foundational technologies that power everything we do at Cohere. We have generative models and we have representational models. Generative models power APIs such as Generate. Representational models do something else. And I'm going to let Nick talk about that now.
Yep. Cool. Thank you, Michael. Okay, so I'll talk about the other side of things. So we're going to talk about the representational models. So the generative models take in text and write more text. That's what they do. They just take in text and they write more text. And what kind of text they write is dependent on what model you're using. So if you're using the command model, it takes in text, which it expects to be a command, and outputs text, which it thinks is the completion of that command. If you're just using the baseline model, it takes in half a sentence and writes the next half of the sentence. That's the generational. The representational takes in text and creates a vector. A vector is just a list of numbers. So it just creates, it takes in text and outputs a list of numbers that represent the meaning of that number. If you're not familiar with ML stuff, that might not be obvious to you why getting a list of numbers that represent text is useful. But it is for a number of reasons. And I'll show that by first sharing my screen. Actually, Michael, can you stop so I can?
If I could figure out how to, that'd be, oh, there we go. Big red button, why not?
Okay. Okay, cool. So this is fun. This is our embedding model. And this is our playground for our embedding model. So here I have a whole bunch of pieces of text. Well, let me zoom in here a little bit. A whole bunch of titles from subreddits. This is like subreddit titles about something, various things. Greenland permanently bans oil and gas exploration. That's terrible. Cool. No, that's great.
That's great.
Yeah, that's great. Anyway, so these are titles from subreddits. And what I'm going to do when I click run here is instead of taking in text and writing more text, I'm taking in text and getting a vector, and then I'm showing that vector on a two-dimensional grid. So now if I look at two things that are close together, that means the model thinks those two things are similar. So for instance, here's two different titles. Non-sufficient fund fees are ludicrous and our government should have outlawed them years ago. And here says, another title is, are you annoyed that taxes are not built into price tags in Canada? Non-sufficient fund fees are, so all of these titles are about like finances and taxes. And so the model thinks they all kind of mean something similar. Over here, what is this? Oh, these are like relationship advice things. That's often spoken about Reddit. Over here, oh, this is all news about England. Boris Johnson and Liz Truss resigned. Okay, so these are all like, this is a little section of only news things. But once we turned it into this vector, we can figure out, are these two pieces of text similar? And we can do all kinds of other things that we won't talk about today. We can classification with this. We can train downstream models for all kinds of things. We won't talk about that. We're just going to talk about using this as a way of understanding, like, are these pieces of text similar? And that's something that comes up all the time in building practical applications with AI. Like the generative side of things, it's very, you can do all kinds of fun things like write down a list of cat names. Yeah. But if you're working with data that a business, like actual business data, you're working with some application, often you get text and you need to know, what is this related to? Is somebody asking a question about this? Is somebody like, is this document similar to that document? Like that just comes up routinely in production deployment of stuff. So that's one of the reasons why we serve this as a model. We just released a new model that does multilingual stuff. So I think we won't talk about that today just because the talk is about English, but we have this multilingual model, and that means you can put any language you want in here. You can put French and English, and there's like 100 different languages in this multilingual model. And if you've said like, hello, how are you? Or if you say konnichiwa, like do desu ka, like in Japanese, hello, how are you? The model will think that those mean the same thing. So that's a very cool aspect of the model. But I'll pass it over to Michael to show what it looks like to use this embedding model in code to solve problems. Cool.
Okay. So there are two questions in the chat, and I'm going to address one of them. I can try to address both of them. One of them is about OpenAI, and they also have embeddings. They also have generations. Why would you use Cohere versus OpenAI? And the answer probably is try both and see what works best for your use case, because they're trained differently. There's also other reasons like pricing and how well like how fast it runs and stuff like that. Nick maybe has a better answer.
Yeah, no, that was a great answer. Yeah. They're a provider of models as well. We have a slightly different focus than they do. We're not an AGI company. We're not interested in creating artificial general intelligence. We're interested in making models useful today. That's one of the reasons why we've invested in the like multilingual embeddings. That's like not necessarily a step towards AGI, but is a super useful business application. But yeah, no, Michael's advice of trying both and seeing what works for you and what's right for your like application is great advice. So yeah, try both.
The second question is, how are people using these APIs? What are some real world cases? Well, let's talk about it. I'm gonna have a slideshow for this.
Oh, that was why I'd say really set you up. That was a great
really
segue.
set me up. I'm not sharing my screen. Let me share my screen. Okay. Let's start the slideshow. First of all, this is my cat Mel. If this doesn't answer your question, I don't know what will. Secondly, imagine you're in a band. Imagine you're in a band with this guy. And imagine your band is called Good Kid, and you've been doing it for 8 years. This is completely hypothetical. Imagine you're on tour and you're traveling the world, you're playing music, you're having a blast. This guy on the top left is just having a day. All these people on the right also having a day. And meanwhile, on your band Discord, people are asking you questions. They're like, how'd you guys meet? How'd you all meet? That's neat. Have you met through programming or not? How'd you all meet? And you're here, you can't answer those questions, but the questions that keep coming and they're very similar. Well, what can we do to help the situation? This is before I joined Cohere, and this is partly why I joined Cohere, because we kept building these cool bots using Cohere for our band Discord. I know Nick through university, and we've been in a band together for a long time. And I got to work with Nick on some of these bots, and I saw that it was really cool, so I ended up joining the company and working on the underlying technology. So yeah, how do we address this? Well, on our Discord, we built this bot that recognizes frequently asked questions and then can answer them using a response that we created for it before. So I can probably show this to you in real life. Here's Ask the Band, and yeah, somebody asking questions. Well, this is actually an excellent example of it failing. Somebody says, how did you guys meet Lovejoy? Lovejoy is a new band that the model doesn't know about, but it's like, well, that sounds similar enough to how did you guys meet? And then it pulls out the answer to that question. But a lot of the time, if I look up this question in the search, let's see, that's this one. Yeah, have you guys met through programming or not? And it's like, yep, this sounds like how did you guys meet? And then it gives you the answer. So I figured this is a useful scenario. It happened in our Discord. In general, a frequently asked question bot sounds reasonably useful. So I might show you how to build one. So I'm gonna go switch to the playground. Actually, I'm not gonna switch to the playground. I'm just gonna look at you. I'm gonna look you in the eyes, and I'm gonna remind you that at the end of the day, Generate understands the text and can spit out more text for you. Embed understands your text. So basically you have text as an input. It will extract the meaning of that text and represent it as a bunch of numbers. Why is that useful? Well, because numbers can be compared to each other. So if we have text 1, text 2, extract the meaning of them, get the embeddings. Now we can compare the embeddings and we can tell whether the two texts are talking about the same thing. So if someone says, where'd you guys meet? And what's your favorite cat name? We can extract the meaning of those, compare, and realize those are actually not that similar. So probably not the same thing. But if someone says, where'd you guys meet? And did you meet in university? Extract the meaning, compare. Yeah, similar enough. Run the bot. So that's kind of what I wanted to show you. Before I jump into the code, are there any questions?
There's one question, Nasai, about ethics and around safety usage, and you've linked to the page that we have about this. So this is more just to talk about the generative stuff. The safety applications for embeddings are like a little clearer cut, I think. But the chat stuff, yeah, there's definitely like misuses of language models. We have a terms of use, and we spend a lot of time pruning the data and getting our fine-tuning data to try to get the model to be aligned with the values of the company, so that we're like happy with the output. So like, yeah, essentially, like, how do we address this? We take a data first approach, and we spend a bunch of time making sure that the data goes into the model is like stuff that the company is pleased with. That's like an ongoing effort, and I think we'll be working on that forever, because it's an important thing, and yeah, there's always improvements that can be made. For the embedding stuff, it's significantly more restricted. There's not very many misuses of an embedding model, although it is, we still like to make sure we run, look at what's coming into the model and try to have an understanding of what people are using it for. Yeah, cool. Okay.
If you have any questions, pop them into the chat. Nick is watching the chat and let me know if something comes up. I'm going to switch into code. So what we want to build is we want to build something that can, given a question, figure out if it matches any of the frequently asked questions. So I'm switching into this frequently asked questions JavaScript file. It's not 3 lines of code, it's about 80, but they're all pretty straightforward, and I'll explain them. We're going to start with having a collection of Q&A. So right here, I prepared exactly the file that we ran our bot with. Is just a bunch of questions and the answers we prepared for them. So for example, people really want to know, what's our favorite musical? Well, mine is Cabaret and Chicago and Producers and Sweeney Todd, and the other guys, who cares? So if somebody asks something about musicals, we should be able to find this question and then use the answer for it. So let's see what we got. This is my file. I'm going to go ahead and make sure that this works before we try running anything else. This is frequently asked questions that. Switching to Postman and Embed, and let's go. So I'm sending in a question, how did you guys meet? And it's responding with hello from Michael, Nick, and Kate. Okay, we can do better. We can answer this question for the user. So let's see what we got here. So the first thing we're going to do is we're going to instantiate Cohere, and we're going to use this Q&A JSON file. So really, and the rest is just like me starting the server, nothing to do with Cohere. There's this function right here, get similarity score. It's very, very mathy, and I did not come up with it. I basically went to our website and I copy pasted this function. Given embeddings A and embeddings B, it can compare them and it can spit out the score. It's kind of annoying that you have to copy paste this function into your code right now. This will get better literally in a couple of weeks.
Yeah, stay tuned. Stay tuned for that.
But for now, you know that there's this function that, given embedding A and embedding B, can compare them and can tell you how similar they are. Great. What I did is I grabbed just the questions from our frequently asked questions list, and then I embedded them, which means now for each one of these, I have an embedding.
Which again is a list of numbers.
It's just numbers.
The list of numbers.
So I have my questions, and now I have my embeddings for those questions. Next up, I'm going to take a user question. So this is me grabbing whatever somebody passes in the request. So in here, I have this question, how did you guys meet? And this is going to get stored in the variable question. Then I do co.embed, and I just pass in a list of text, which in this case is just one text. It's my question. I get the embeddings back, and I store the question embeddings right here. So now I have question embedding, and then I have all the embeddings of the frequently asked questions. Now the only thing I need to do is find the best match. So here I call this find matching question function that I wrote right here. It just goes through all of my frequently asked questions. It calls get similarity score, grabs the score, and then finds the question that has the highest score, and then returns the index and the score for that question. Great. So we found our best match. And yeah, we can now send that question back. So let's do that. Let's run this. And Nick, you ready? Where'd you guys meet? Okay, so what it did is it found the most relevant question. And the question is, where'd you guys meet and how'd you start the band? And the score is 0.71. I'd say that's a good similarity. Probably means it's this question. So how about now, in addition to returning the question, we can also return the answer. So let's do answer. And then let's do what do I call this? QA at the right index. And then I think it's called answer.
It's called answer. Yeah.
It's called answer.
With a capital A.
With a capital A. Let's see if this works. The answer, Jacob and David met in high school. The rest met in various ways at the University of Toronto. Jacob and Michael met in German class. It's true. I don't speak German, kind of sucks, but I have a minor in it. Michael and Nick met in computer science classes. It's true. Nick and I met in a computer science lab. He was very smart. I was smiling a lot. It was a great time. Yeah, and there we go. We wrote a bot that, given any question from anybody, can figure out if it's one of the frequently asked questions and give an answer for it. I think it's pretty cool. And for our band,
it's helpful.
Yeah. It's exploded us into the stratosphere of rock and roll.
That's not true. It's also, so one of the things on that bot that is to like productionize it, we had to add a few other things. One of them is a call to co.classify to figure out if what is said in the channel is a question. Because sometimes if you say like, oh, I don't want to call the bot if the people are just chatting, I don't want it to interrupt. So there's a call to co.classify. We won't explain that, but that's an endpoint that exists as well. You can give it a few examples of labels as you want it to classify, and then you pass the message in and classify it. The other thing we had to do is set a threshold to say like, at what level of similarity are we comfortable returning the result? The trade-off is the lower that threshold is, the more often the bot is going to respond. But the more likely it is to get wrong. So do we want to say only respond when we're like very confident that this is the right answer? Or do we want to respond when we're like kind of confident? And that's just a trade-off of like how annoying you want the bot to be. But those are the only things we took to productionize it, other than what Michael showed you. Otherwise, that's pretty much the whole code. Like it's plugged into Discord, which integrates with the Discord API. But because our API is always just, it's a network-based, it's a network-hosted thing. Like you call that Python code, sends a message to our server, and you get the response back. It's very easy to productionize this stuff. I see there's a question from Alex on what are the pros of using a proprietary fine-tune model like yours over open source. So there's a few of them. One of them is that like, we don't just create models, we host them as well and create the APIs around that to use it. So like our models are always hosted. We have good SLA metrics. We're constantly serving the biggest, best models we can. And if you can ping that via a network and go to production very easily. So if you download some large model and you want to host it yourself, you need to worry about like what GPUs you have. Do you have enough to handle the traffic? Things like that. If you want to just, like Michael and I a while ago made a little fun website that generated Magic the Gathering cards with our API. And it got on the front page of Hacker News and like blew up. And we never worried about the load once because that website was just pinging Cohere servers, and Cohere servers scale and handle it. That's like the hosted side of things. There are companies out there that like host GPTJ or Neo, those things. The other answer is like, the models are just, like, they're just better. They're bigger, they're larger, we train them for longer. When we evaluate our model compared to open source stuff, we're significantly beyond where they are. And that's especially true now that we're fine tuning on human feedback. So now that our models are like trained not only just on base text, but then fine tuned on data that we're specifically curating to make them useful. I imagine over the next little bit, open source will continue to be an important part of the NLP community. And I think there's gonna be some great small models that will come out of that. And if your use case requires like something that you can host yourself and that a small model is good at, then open source would be a good place to look. If what you need is a hosted solution of a state-of-the-art massive model that's prohibitive for people to train, I think it's probably going to be in companies like us. But always good to look at what's out there. Yeah, cool.
Yeah, I think there's only two more things I wanted to say.
Okay.
Thing number one is that, like, we talked about generating text and we talked about understanding text. And those are the two underlying technologies that we work with at Cohere. And then what we do on top of that is we build APIs that take common use cases of those technologies and make it as easy as possible to just use them. So, for example, you saw the beta of the Summarize endpoint. This is something we're working on right now, and will be out in the world sometime soon.
You just leaked it.
It will never be out in the world.
Okay.
Yeah, the goal is, look, people summarize text very, very frequently. So you should be able to just say code.summarize, pass it an article, and it will spit out a summary for you. This is cool because this solves real life problems for people. And what my hope is that you will look at these APIs and be like, wait, this reminds me of like an idea I had for an app, or this could be useful in my app. And then you will start using it and you'll tell us, hey, I've actually been using your API like this or like that. And then maybe we'll just build a dedicated endpoint for other people to do something similar to what you're doing. So I strongly invite you to join our Discord if you're not in our Discord, because we hang out there all the time. And if you run into problems and you have any questions, you can just tag us and ask a question. We'll help you get set up.
For sure. So you had two things. Was that both things?
That was thing one.
That was thing one. Okay, what's thing two?
Thing two requires remembering thing two.
Okay, I'll answer this question. You remember thing two. Alex, you have another question about a huge complaint about existing LLMs is that they hallucinate or make things up. Have you guys thought about how to circumvent factual errors? Yes. Okay, so an important note about language models. They have no notion of truth. They have no idea what's true or what's not true. They're not truth models, they're language models. They're just models trained on the web first, and the web has all kinds of true stuff and all kinds of not true stuff. And it has things that were true a few years ago and are no longer true now. And it has things that were never true and never will be true. So yeah, they're not goods. They're not oracles of truth. Like, I do not recommend going to a language model and asking a question that you want the truth from. I recommend using a language model as an interface for other sources of information and other source of truth. So yeah, I have an open source project called Grounded QA, which thank you for posting in the chat. And that's using a language model plus the embedding stuff that Michael was just talking about. So that, and plugging that into Google search, and Google search acts as like a decent source of truth. So it's, when given a question, Google searches something, finds relevant text using the embedding stuff that Michael just explained, grabs that relevant text, and then tries to answer the question based on the text.
Like, imagine for a second that you are an engineer, you're a developer at a company, and you're on call, and a 500 pops up, an error. And you're like, what do I do? You could just go and ask Cohere, I see a 500, what should I do?
Yeah,
it will give you maybe something, but what you could do instead is find the relevant section of your on-call runbook using embeddings, like I showed you how to find a comparable frequently asked question. Now that you know the section of the document that's kind of relevant, you can plop it into your generate prompt, and you can say, knowing this information, I have a 500, what should I do? Mm-hmm. And now it will reference the information from your source. Mm-hmm. So kind of what Nick was saying is, if you say like a factual question, how many children does Joe Biden have? Our model could invent you how many children Joe Biden has, mm-hmm. or you could go find the information on Google. It probably will be an article or a paragraph or something. You can plop it into the prompt and say, like, knowing what you know from this, how many children does Joe Biden have? And it will tell you the correct answer.
Yeah. Yeah. So that's where I think like the real value add from language models is. It's in working as interfaces. As we go down the like fine tuning on human feedback, we get closer to the like, you can ask it things and get useful information out of it, because we're, then when we collect data for fine tuning on command, we're asking people to write things that they think are true. And so it's like it's more likely to output the correct stuff. But, for instance, we collected some data for command if you asked like, who is the prime minister of the UK? Well, that's changed a lot in the past few months. And so there's sometimes when someone might have put in one thing, a few weeks later, they put in something else. So even there, like, even though everybody's trying to give true information, the truth is literally changing as time goes on. So yeah, I think language models, they'll ultimately be interfaces for databases that are sources of truth and not sources of truth themselves. Yeah.
Cool. This just in, there's a new prime minister of the United Kingdom. Congratulations.
Congratulations,
Britons.
Oh, wow. Okay, another question says, I'm a student here and I was wondering how you guys use statistics to make these models predict better. A secret for you, in some ways, it's all statistics. In some ways, in the end, like what these models really are statistical models of sequences of language. So you can imagine a really, really simple like statistical model for predicting language. Imagine if I like took a book and I counted all the occurrences of two words next together. And I noticed that every time I say hello, 80% of the time it was hello there or something. So I just made a statistical model that would take the first word, look at what the likely words that came next were, and then predict one. That would be like the first statistical model of language, and that wouldn't be very good. But now we just, instead of having a lookup table, we replace that with a neural net, but otherwise we're doing the same statistics. We're just trying to learn the relationship between sequences of words. So yeah, it is just all statistics in the end.
I remembered the second thing.
Oh, yeah.
I'll let you address the question after. The second thing I wanted to talk about is that we trained those models. We trained them on a lot of text on the internet. And that means the answers it's going to give you is it's going to try to sound like what it's on the internet. However, if you want to, and if you have a lot of information, you can train them additionally on top of that on your information, and then it will really, really try to sound like the kind of stuff you taught it with. So for example, if you are building a chatbot and you have a bunch of examples of what a chatbot should sound like in your application, we call it creating a custom model or fine-tuning. You might have heard Nick talk about fine-tuning. It means take a default out-of-the-box Cohere model that's seen Wikipedia, Reddit, and all this other stuff, and now really show it the information that you want it to start spitting out and train it on it. So it's going to start reading all the information that you showed it. It takes a couple of hours. I can show you later what it looks like on our website, but basically you go to the dashboard, there's a section about models, and you can click create custom model. And then you'll upload your files and it will start this fine-tuning process, at which point it will be done. And now it will heavily weight what it saw in those files as opposed to Reddit and Wikipedia and whatever else it saw before. So this is a lot of the time really useful if you're finding that the model kind of sounds generic or it doesn't speak in the right tone of voice or something. You can train it on your personal data and then it will sound more like what you want it to sound like.
Cool. Oh yeah, I see why you. Yeah. So yeah, I think the reason why Michael wanted to talk about the fine tuning is that, Alex, that does get to your question. So if you're like fine tuning with us, you upload our data set that like goes to our servers to fine tune, but then we don't use that for like creating the base model. The base model is only the stuff we get from the open web, and then the data that we create for fine tuning for the command following and for chat stuff. So no, if you upload a fine-tuned data set, we're not putting that into the base model. We wouldn't want to. It's like most of the time when I've found people are fine-tuning, it's a really specific use case. It's like their data, it's for them. We have stuff in place that we won't fine-tune on it, but mostly what we're looking to get is like really generic web text, then really specific command stuff. So yeah, you fine-tune, that's never added into the base model.
There's another question about how ChatGPT, when you talk to ChatGPT, instead of waiting, get the answer, you start getting the answer word by word. And the question is, do we do that? And the answer is not yet. Do hold your breath.
Wait. I was like, under the hood, yes, it's the same thing. Like these are called autoregressive models where they predict one word at a time. Our API right now, we don't return like a word at a time because that slows the whole generation down. So if you know you want like 100 words, it's going to be faster to get all 100 words and then return them to you than it would be to get 1, 2, 3, 4, 5. So when we built the API, we prioritized just like getting the whole thing to you and returning it. Most production use cases like the JSON extraction or summarization, I find that's normally what's best for people, but a lot of people have been asking for it, and so we've been working on the streaming thing as well.
Yeah, so the streaming thing, while it takes a little bit longer to get the generation,
can make the UX
it's nice for if you're building a UI where the user is seeing stuff appear as it gets created. It's a nicer experience. So we're gonna do both. Why not both?
No, why not both? No.